Good morning, everyone. Let's go over these two questions. I will say we're going to teach you two different ways to do problems like this where you have to evaluate a trig function. First off, we don't want you to use your calculator on this. It is most likely going to be a problem when you see in the future pre-calc or calculus. These are questions that would be involved with a no calculator type of problem. And you'll notice they are special kinds of angles. So here's how I would approach this. When I think of 5 pi over 4, what I really think of is, well, it's 4 pi over 4. We're 1 pi over 4 away from 4 pi over 4. So if I went 4 pi over 4, which remember the 4's cross out, that's pi. So we know pi is right here, and if I go a fourth of a pi past that, so I would go all the way around until I go a fourth of pi. Now, a fourth of pi is 45 degrees, and that's what helps me with my reference angle. All right. Now, one of the things to think of is the idea of coterminal angles. And we have to be very careful with this, but the value of 5 pi over 4 is really the same as the sine of pi over 4. The only difference is the sine value could change. So we have to be careful with this. This isn't 100% true. But that's what I'm thinking is what is the sine of that pi over 4? Well, the reason why I draw my triangle, my reference triangle, and the reference angle of 45 degrees is we have these special side lengths then. This side length is 1, this side length is 1, and then this hypotenuse is square root of 2. And those are the lengths we told you guys we remembered from geometry. However, we have to be really careful because I went 1 to the left, so that's a negative, and I went down 1, so both the adjacent and the opposite side are both negative 1. All right? So now I'm thinking of SOHCAHTOA because this is a sine function. And SOHCAHTOA tells me sine is the opposite side over the adjacent. So my reference angle is 45 degrees. Opposite of that is negative 1. And the hypotenuse is square root 2. And then we just got to remember that we don't keep our answer with the radical on the bottom. We have to rationalize that. So I end up with negative square root 2 over 2. So I'll admit this is the way that I do these problems all the time. Today we're going to introduce another method that is much faster once we set it all up. So if you do the work to understand the unit circle, you can look at it and you'll know this answer in a second. All right, so you'll see the benefits of each. Let's look at this one. 2 pi over 3. So we've got secant of 2 pi over 3. Well, when I'm thinking about this, I'm thinking of, well, what if it was 3 pi over 3, right? The 3's cancel out, and that's going to get me to pi. But I'm not there. I'm 1 pi over 3 away from being all the way across the circle. Well, pi over 3, if I split pi into 3 equal chunks, and I go 2/3 of that, now all of a sudden my reference angle is right here. And that's a pi over 3 reference angle. But as we know, pi over 3, pi divided by 3 or 180 divided by 3 is 60 degrees. So we get a 30, 60, 90. And that's our other special right triangle that we have to remember the side lengths. Across from the 30 is 1, across from the 90 is 2, and across from the 60 is square root 3. But notice how I went to the left. So that's a negative side. And then I went up to get to this location. And that's a positive. And the hypotenuse is always positive. All right, well, then we got to think, well, what is secant? Secant is the reciprocal of cosine. And if I know cosine is adjacent over hypotenuse, that means that secant is hypotenuse over adjacent. So then I got to look at my triangle. My reference angle is always formed from the terminal side and the closest x-axis. And the adjacent side of this reference angle is negative 1. The hypotenuse is 2. So I'm going to put the ratio of 2 over -1, or we could just call that -2. So that's how we evaluated special trig functions from 45, 45, 90, or 30, 60, 90. This is really going back to geometry. Um, so I hope you have a very strong familiarity with this and the use of SOHCAHTOA. And if you do, you could technically use this for every problem that you see. It just takes a little bit of time setting this up. Okay? All right, I've got one more warm up I'd like you guys to do here quick. And this is, you could maybe just do it in your head, but it's identifying the coordinates of the angle measures, coordinates and the angle measures in degrees of the 4 quadrantial angles. So what happens if I cannot form a reference triangle? What are the locations? Because those are really, excuse me, those are really important today. So I'd like you to give the degree measure in radians and degrees for each location, as well as their coordinates, their ordered pairs. So take a minute or two to fill this out. All right, let's go over this really quick. The way I like to think of these problems is I think of them in degrees first. So if I'm at this spot right here, I'm at 0 degrees. And then if I go a quarter of the way around the circle, that's 90 degrees. If I go halfway around the circle, that's 180 degrees. And every quarter is an extra 90 degrees. So that would be 270. And then finally, another coterminal angle is 0 is 360. So there's my degrees. And then if I do the radian measures, this is the way my brain works. I know that pi is 180. And I know that if I cut pi in half, I get pi over 2, and that's 90. And then 0 degrees is the same as 0 radians. And if you want, you can write radians or just RAD. But then I'm thinking, all right, every quarter of a circle is a pi over 2. So this could be written as 2 pi over 2, but the 2's would cancel out. But then this one would be 3 pi over 2. And then if I go back here, a coterminal angle of 0 would be 4 pi over 2. But 4 over 2 is 2. So this would also be known as 2 pi. So there's my degrees and my radians. Hopefully you're really familiar with that. And now we have to think of the unit circle. Okay, and we're going to get into this quite a bit, but the radius in the unit circle is going to be equal to 1. And what that does is that gives us the location of the xy pairing on every quadrantial angle. So if I'm here and I go over 1 to the right, this length, the radius from the center to the rim, is equal to 1. So I'd go over 1, up 0. And that will put me right there. And notice that is my x, y value. And then if I go over 0, up 1, over 0, up 1, there's my x, y pairing at 90 degrees. Then what if I go to the left? Well, then I'd go -1, 0. There's my x and my y. And then I would go over 0, down 1. And I'll let you in on a little secret. These 4 angles, these 4 quadrantial angles, either degrees or radians, are very, very important to kind of have mastered going into pre-calculus, or excuse me, going into calculus. So here's what I mean. What if I told you to find the sine of pi? Okay. Now we do know, and there's multiple ways to think of this, but we know that from our work from last week that the sine value is the y over r. It's your y value over your radius. So all I'm going to do is if I know this location, I know the radius is always 1. The radius will always be 1 in the unit circle. So what does that mean? That means that if I'm dealing with the unit circle and the radius is always 1, then the sine value is just the y. So if I look at this, here's the y value at pi. So my answer is equal to whatever that y value is, which is 0. Okay. Now, what if I asked you to do cosine? Cosine at pi. Well, we learned the other day that cosine was x over r, but the x value, or excuse me, the radius is always 1. So then all I have to do is say, all right, well, at pi, what is the x value? So I'm going to go and find pi. The x value is -1. And there is the value of cosine of pi. Okay. Now, let me just quick do tangent. We decided, or we knew that tangent from the other day, tangent was the value of y over x, or you could say sine over cosine. And notice you got your answers here. So I'm going to introduce this one a little bit. It actually doesn't come up until next week, but might as well show it to you now. Tangent is really the ratio of sine over cosine. And the reason we can write that is we know that sine is equal to y over 1, or just y, and cosine is equal to x over 1 in the unit circle, or just x. So what does that mean? That means if I'm evaluating tangent, all I'm going to do is take the sine value over the cosine value. And some students like to write this up here, sine, cosine, because they see the sine of pi is 0. These are my answers in the ordered pairs. So I get 0 over -1, which is the answer of 0. So if you feel like you've got these 3 down, you also should be comfortable with their reciprocals. Because what is the reciprocal of sine? That's cosecant. Right? Cosecant is the reciprocal of sine. So instead of y over 1, in the unit circle, that's 1 over y, or 1 over 0, which we can't divide by 0, so that officially is undefined. Okay, and then what about cosine? Its reciprocal is secant. So secant of pi is the reciprocal of x, or in this case it's 1 over x. And we know what x is. At pi, the x value is -1. So that's what's going to go right here. And then I just can simplify that. And the secant of pi is -1. Okay? And then the last one, cotangent, is the reciprocal of tangent. So we could think of it as if tangent is sine over cosine, then cotangent is cosine over sine of those values. And notice, we know what sine is at pi and what cosine is at pi. So cosine is -1, and sine at pi is 0. And since we can't divide by 0, this is undefined as well. All right? So there's a lot. We're developing this idea of the unit circle. Right here, I showed you how to use it just at the quadrantial angles. The nice thing is that if I move one of these points, and let's say I put it right here, all that changes is it's a different reference angle. So if I'm right here, it might be pi over 4. And then the location changes. It has a different ordered pair, but the way we think of these is exactly the same. So you're probably not super confident with this, and I completely understand. I want to talk really quick about Wednesday. Yesterday, you were expected to watch the video, and I went through and just explained what the unit circle was and why we use it, or in terms of evaluating trig functions. I gave you a link to a printable PDF, and some of you may have printed that off. It's a blank unit circle, and that way you didn't have to draw it. But then what we did was I showed how just the angle measures and the degrees were formed. We didn't even deal with the coordinate pairs yet, and that's what we're going to be doing today. Is we actually just talked about the angles for the 4 quadrants. So we have those 4 quadrants fill in. Now we're going to fill in all the rest of these. And I'll give you a little hint. Everything is based off of the special right triangles. All right? So here's what we're going to do. And I don't want you to write this part here today. Okay? At least this part. I just want to talk about the sign values that go around the quadrants, so we know what to expect if I'm in quadrant 1, quadrant 2, quadrant 3, quadrant 4. Once we develop this, I have something that will automatically fill this in that you could use, or you can just write it in on your sheet that you started on Wednesday. But let's just take a look at this idea of, well, what happens if I have a location right here? Let's say I'm at this point here, which I'll just share with you this reference angle. If I go from the ground, I shouldn't say the ground, if I go from the x-axis, the starting position, to the terminal spot, I went 45 degrees. So this angle here would be 45 degrees, or pi over 4. But then my goal is, what is the value of this point? Well, what did I do? I went to the right in the positive direction, and I went up. And both of these values are going to be positive. And that will be true if I'm at any location in the first quadrant. X is positive and Y is positive. Now, we saw in the last slide that the Y value is always the sine of that angle. And then the X value is always cosine. So there's a reason why we want to figure out what the ordered pairs are for each one of these spots. And the X value always comes first, and then the Y. But we know that in quadrant 1, sine and cosine are both positive. Well, if tangent is sine over cosine, that means all the values. Tangent is positive here, and then their reciprocals are positive. So in quadrant 1, all values are positive. Okay? And Ms. Dwyer talked about this in her video last week as well, so this shouldn't be anything brand new. But now let's look at what's happening here if I'm in quadrant 2. Well, what's the behaviors of any point, I don't care where it is, any point on the unit circle. Let's pick this one. What's the value? Okay, now it doesn't really matter right now, but this is a 30-degree reference angle. So I would put a 30 here, and then this would be a 5 pi over 6 for the radian measure. But what do we do? Well, notice, what did I do? I went to the left one, so that's a negative value, and then I went up, so I'm positive. So my x value is negative, and my y value is positive. But as we saw in the last example, the y value is always sine, and the x value is always cosine. All right, so this tells us a little bit something, that anything that involves sine will be positive. So sine and its reciprocal are going to be positive. Anything that involves cosine, which is cosine, its reciprocal secant, tangent, and cotangent, all involve the x value. So that means those 4 values will be negative, and the only 2 that are positive are sine and its reciprocal, which is cosecant. Okay, so those are positive values. And again, we'll share a lot more with this, but what if I have a point that's in quadrant 3? Well, you'll notice here, if I pick any random point, let's pick this one. Okay, notice I went to the left, and then I went down. So my x value is negative, my y value is negative, which tells me that y is always the sine value, and x is always the cosine value. If both of those are negatives, then their reciprocals are negative. The only value that's going to be positive in quadrant 3 is tangent. So why is tangent positive? Because tangent is sine over cosine, which is going to be a negative answer divided by a negative answer, which ends up being positive. So we know that in quadrant 3, tangent and its reciprocal are both going to be positive. And maybe if I write this out, the reciprocal of tangent is, instead of sine over cosine, it's cosine over sine, which is a negative divided by negative, which ultimately ends up being a positive. So there's something we know about the values of each one of these, depending on the values of the x and the y. And the last one, quadrant 4, well, notice if I pick a random point right here, what did I do? I went over to the right in the positive direction, but then I go down to get to this point. So my y value is negative and the x value is positive, which again, x is cosine, y is sine, and then we can say anything that involves a sine will be negative. So that's sine, cosecant, tangent, cotangent are all negative. And anything that involves just cosine or just the x, cosine and secant, are positive. All right, so that's kind of a lot. But again, when we talk about the sine values, we want to think of the x and y pairing. Okay? All right, this is the part. What I would like you to do is on a separate sheet of paper right now, not really continued on what we did on Wednesday. We're going to do that on the next slide. But what I'd like to do is just generate the first quadrant. Okay, if we can generate all the values for the first quadrant, then we're going to, if you have this memorized, then we can just reflect all the values and it makes this unit circle less cumbersome. So I'm going to pause for a moment. And quadrant, you'll be in really good shape. And it's not as it's not as scary as it might look. So start off with degrees. If I'm at 0 degrees and I go 90 degrees, right? That puts me at 90 degrees. Well, if I do half of that, if I cut 90 in half, that puts me right here at 45. And then we have to just kind of know that this is a 30-degree angle here. This reference angle is 30 degrees. And if I go another 30, that puts me at 60. So those are angles. And then we got to deal with the radians. Well, I know that 0 radians. And if I go 90, that's half of pi, so that's pi over 2. And how do I get 30 degrees? Well, pi divided by 6 is pi over 3. If I cut pi over 2 in half, that gives me pi over 4. And then if I go another 30 degrees, that's 2 pi over 6's, but 2 pi over 6's is a pi over 3. So there's my angles in both radians and degrees. Nothing super special. What I want to do, and you don't have to draw this red triangle in, I'm going to kind of move it, but this is just a visual. Let's focus on the fact that we know we have the unit circle. All right, so I've got a 30, 60, 90. Sorry, hold on one second. Okay. So I've got a 30, 60, 90. So let's just pretend this was a geometry problem from back in the day. And we had a 30, 60, 90, right? We knew that in a 30, 60, 90, I had a 1, 2, square root 3, right? Those are our special right triangles. However, we know that for sure this length right here has to be 1. All right? And that's what allowed us to fill in, and maybe I should have done this in the first place, this length on the bottom all the way to right here. This was at the spot, go over 1, up 0. And then at 90, I went over 0, up 1. Okay, and those will always be the numbers for 0 and 1. But what is the location of the 30-degree reference angle? Where does that point end up? Well, I have to have a radius of 1. So if it was a 30, 60, 90, and we knew these special values from geometry, I need to turn this into a 1. So what I have to do is I have to divide it by 2. But if I'm going to change everything, I have to divide all of them by 2. So now, look at this location. All right, I changed the hypotenuse to a 1. The x value, how far did I go? I didn't go all the way to 1. I stopped short of it. Well, how far did I go? I went square root 3 over 2. So that's my x value. So I'm going to put that in the first quadrant, or first value, square root 3 over 2. And then how far did I go up? Well, I went up 1/2. Make that look more. So this little bar right here, that's to represent a fraction. And eventually we're going to talk about patterns. Okay? So that's how I found the value here. Now I'm going to erase all this because I don't want this to get super cluttered. It's already going to be a lot once we fill it all in. But where did those locations come from? They came from, here's the x value, and here's the y value. So square root 3 over 2. Okay? Now, what if I do the 45-degree angle? And let's do that in maybe bright green, maybe that'll show up. So if I want to map 45-degree angles, I got to go over a certain value for x, then I go up a certain value for y, and then I go the hypotenuse. So I've got this special right triangle. Well, that special right triangle is just a 45, 45, 90. Let me move this out of the way. So what if I pull that over to the side? And I'm just going to shrink it so I can write better. But I know that the hypotenuse is 1 right here. That's a 1. The reference angle is 45, and we always draw it so it's a 90-degree angle. So if I deal with that green triangle, I've got 45, 45, 90. And then I'm thinking, well, wait a minute. This was a special right triangle from geometry, right? And across from each 45s, those are both the same. That was always 1, 1, square root 2. Okay? But it's the unit circle. This radius has to be 1. So I need to get rid of, I need to turn this into a 1, which means I have to divide, oops, I don't want that. I have to divide by another square root 2. I'm going to do that in blue. Now here's the nice thing. You're not going to have to remember, sorry. You're not going to have to remember how we did this. But I need to turn this into a 1. So I'm going to divide that by a square root of 2, but I have to divide everything by a square root of 2. So this becomes square root of 2 over square root of 2. Well, that's 1. There's my hypotenuse of 1 that I wanted. So what are the new side lengths? Well, we could leave it like this, but mathematically, we don't like to have the square root of 2 in the bottom. So I'm going to multiply by the square root of 2 top and bottom, and that turns into the square root of 2 over the square root of 2. Now we notice something. This is an isosceles right triangle, so if I do the same work over here, it's going to get me that same length. Well, okay, now this distance along here is the square root 2 over 2. That's the x value. I went square root 2 over 2. And then the y value is the same thing. So instead of writing all this in its triangle, we just put that as the xy pairing. So what was the x? It was a positive square root 2 over 2. And what was the y value? It was a positive square root 2 over 2. All right? So now I'm going to get rid of this green triangle. I'm going to get rid of kind of all the extra pieces because we don't want all of that in there. We just want the ordered pairs. Oh, wrong button. Hold on. Okay, so now the last part is what about at this 30, 60, 90, or this 60-degree triangle? Well, you'll kind of notice something here. So I'm going to use the same color. If I go over a certain x value and I go up the y value, and that's going to get me right at this location, and we know the hypotenuse has to be 1. So I have another special right triangle, but this reference angle is 60 degrees. And then we've got a 30 up here, and I've got the 30, 60, 90. Well, wait a minute, I already did all the work for the 30, 60, 90, but now it's drawn differently. So if you want to, you could redraw this so it's kind of a taller, skinnier triangle. And that would put the 60-degree angle here and the 30 here. Now I'm going to take the same values across from the 30. We call that 1/2. So this value is 1/2. Across from the 60 is square root 3 over 2. And then because it's the unit circle, instead of being 2, we divided that and it came into 1. So now this is the triangle that I would draw right here. So x is 1/2. Y is square root 3 over 2, and the hypotenuse is always 1. So I went over 1/2, and I went up square root of 3. And that's how those numbers are generated. Okay? So I'm going to get rid of this triangle and all that extra stuff. And what I hope you realize is these numbers, these ordered pairs, they came from the special right triangles. So the nice thing is once you have this written down and you know their locations, then you can kind of easily just memorize it. And now all of these are just going to be reflected over into the other quadrants. So let me show you this really quick. And here's a couple of things to remember just to memorize. My recommendation is you should have the 4 quadrantial angles that we talked about earlier completely memorized. And we just know that because the unit circle has a radius of 1. If I cut this in half, okay, the 45-degree angle, notice it's always square root 2 over square root 2. And by the way, notice how everything, all of these pieces that are not on the quadrantial angles, notice how they're all divided by 2? There's a pattern right there. So one way to remember, and there's multiple different, like, I don't want to call them cheat codes, but there's multiple ways to remember the values of each one. So how do I know the 30 degrees? Well, 30 degrees is going to be the longer x value. So square root of 3 is longer than 1. So I'll have square root of 3 come first and then a 1, because I'm only going up half of the value. Okay, and then if I go right here at the 60-degree angle, well, watch this. I go over half the value, right? So if I stop right here, I go half the value of the circle, and then I have to go up. So that puts the 1/2 first, and then the square root 3 is in the y value. And they're all divided by 2. So that's just one way to memorize, and there's small patterns that you can do to actually kind of memorize this. So what are we going to do now? What I'd like you to do is I'd like you to take your work from Wednesday. All right. On Wednesday, you were asked to create this. Draw this in your notes. So go to that page. If you didn't do that, then you're going to have to do some extra work and you're going to miss out on what we're doing right now because you didn't do that on Wednesday. But you should have this already filled in, and the only thing we're missing then are all of the values for the XY pairing. All right, so here's what we got. We're going to regenerate the unit circle from quadrant 1, and we already know these, and hopefully you already have the quadrantial angles in, right? Because this radius is 1, so I've got 1 comma 0, and then I've got 0 comma 1. If I go to the left, that's negative 1 to the left and 0. And if I go down, that's move over 0, down 1. So we already have those. Here's the way I would like you to do it. Okay? Do this systematically. Watch what happens when I go to pi over 4. Okay? We know that pi over 4 is the exact same x and y value. It's the only one that's the square root of 2 over the square root of 2. Square root of 2 over 2, comma, square root of 2 over 2. So what if I reflect this? What if I take this point and I bring it right here? Okay, I'm not sure if this is going to work the way I want it to. So yeah, that worked. If I flip this point over the x-axis, what did we do? I went to the left and then up. Well, the values, square root of 2 over square root of 2, square root of 2 over 2, and square root of 2 over 2, those are the same. I went the same distance. The only difference, I went to the left and then I went up. So if I go to the left, the x value is negative. And if I go up, the y value is still positive. All right, so we're going to deal with the 45-degree angles first. And I'd like you to find these two other green ones. What happens now if I reflect this point down? That would bring me at 5 pi over 4, or 225 degrees. But think about your ordered pairs. You should automatically know what these are. I went the same distance to the left, but instead of going up, I go down. So hopefully you wrote square root 2 over 2, square root 2 over 2. And then I went to the left and down, which means both of the x and y values are negative. Okay, and then I finally flip. You have a couple ways to think of it. I either flip this side over, or I like to think of it as the first quadrant. What did we do? We flipped down. So I went over the same positive direction, square root 2 over 2 for x, but instead of going up, now I go down. And that means the y value is negative. Right? So what about the 30-degree angle? So what if I go here? Well, we know what that is. This is the longer length, so that should have the square root 3 in it. And then I went up half the value. I went half the way to the top. So we know for sure that this is square root 3 over 2. And then I went up 1/2. All right, so now what if this point is reflected over? So now I'm pi over 6 up from this axis. So if I go pi over 6 up, that puts me at 5 pi over 6, or 150 degrees as my reference angle, or as my total angle. But the values are still the same. I went the same length, except for I went to the left, and I still went up. So square root 3 over 2, up 1/2, and that puts me at the location here. And remember, this is an x and a y. This is a sine and a cosine. Okay? And then what if we reflect that down? What if instead of going up 30 degrees, I go down 30 degrees? Okay, that puts me at 1 pi over 6 past pi, so 7 pi over 6. Well, I still go over to the left, negative square root 3 over 2, but this time instead of going up 1/2, I go down 1/2. Okay? And then again, you can think of reflecting this one over here, or you can think of reflecting, instead of going up 30 degrees from the x-axis, I go down 30 degrees. Either way, that puts me at this piece here. So notice my direction. I went over to the right, square root 3 over 2, but now I go down. So it's a positive and a negative. X is positive, Y is negative. It's just locations of points. That's all it really is. And then the last one is the 60 degree. So this is the way my brain works. If I go over the short distance, notice where it stops. That's exactly halfway to 1. So that halfway tells me the x value is 1/2, and then I go all the way up. And that's the longer length, so that would be the square root 3 over 2. And notice they're both positive. So I went over 1/2, up square root 3 over 2 to get to this location. Well, this is just reflected over, so I'm still going to go over halfway and up square root 3 over 2. But I went over to the left, so the x value should be negative and the y value is positive. And then if I reflect this downward, I still go over half and down square root 3 over 2, but I went over to the left and I went down, so that value is negative. So I have negative 1 over 2, negative square root 3 over 2. And the very last one is just a reflection down. So I still go over to the right, positive direction, and down, so y is negative here. Okay, so why is all of this important? Right now, you might just say, we just spent a lot of time and we generated the first quadrant, and then I just reflected things over in each quadrant, and I know the sign values. So what I'm going to do is I'm going to share a link with you. And you're thinking, why didn't you do this right away? It is exactly this. I would recommend, if you have the ability, to print this out. Okay? If you are watching this video and you don't have the link that I sent in the chat, then you can just type in filled in Unit Circle PDF. Google that and this will come up. But notice it tells me what's positive in each quadrant. And we talked about that. Why is it positive? Because sine is the y value. And notice all the y values are positive here. So sine and its reciprocal are positive. Everything else is negative. Okay. And then all the values are positive in quadrant 1. There are no negative values. And then tangent and cotangent, because x and y are both negative, tangent is y over x. So negative over negative would be positive, same with its reciprocal. And then that means sine, cosine, and its reciprocals are negative. And then in quadrant 4, cosine is positive because cosine is the x value. And then its reciprocal. And all the other ones are negative because sine is the y value. So now that we did all this work, you're probably still thinking, why? I don't get this, Chubb. Why are you wasting time on this? Here's the benefit. What if I asked you to do cosine of pi over 4? You don't have to do any more work now. What you need to do is you need to identify, all right, well, what is cosine? Okay, cosine is the x value on the unit circle. So you have to find the reference angle of 7 pi over 4, which is all the way right here. And then your answer is what is the x value? It's right there. Square root of 2 over 2. You're done. Okay. Now, what if I make it harder? What if I say cosecant of 4 pi over 3? That's a little more challenging. What you need to think about is, okay, cosecant is the reciprocal of sine. So I always write it like this. But if sine is the y value, then that's what I'm looking for, which I probably don't want to write it like that. I want to take the reciprocal of the y value. So I'm going to find 4 pi over 3. Where is 4 pi over 3? It's right here. And then I know the y value is negative square root 3 over 2. So I'm going to take the reciprocal of that because it's cosecant. So I'm going to write 2 over negative square root 3. But I don't love this answer because the square root of 3 on the bottom has to be changed. So we'd write this as 2 square roots of 3 over 3. And then the negative, I always put the negative on top. So if it's not sine or cosine, then you have to do a little bit more work. Okay, we're going to practice this a little bit and give you guys some comfort in how do we do this. Because that's what this really takes. So let me show you some really quick, friendly ones, just so you get the idea, and then I'm going to have you practice some more challenging ones. Don't write this. We're going to go really quick. But here's the way my brain thinks. Every one of these ordered pairs is an x comma y. And when you have x, that's your cosine answer. When you have y, that's your sine answer. And then the only other thing you need is, remember, tangent of any ratio, so tangent of an angle, is really the sine over the cosine. If you know those three things, plus the reciprocals, you can do these very quickly. Okay, so again, don't write this. Let's just go really quick. Cosine of pi over 4. Well, cosine is the y value, so I'm going to find pi over 4. I'm sorry, oops, I said that wrong. Cosine is the x value. So I'm going to find pi over 4, which is 45 degrees, and then I'm going to look at what's the x value. It's square root 2 over 2, and it's in the positive direction. So if you want to put the sign, you can. So what about pi over 6? Sine is the y value, and I'm finding pi over 6. So pi over 6 is 30 degrees. The y value is 1/2. We're done. So what about cosine of 4 pi over 3? All right, cosine is the x value. So 4 pi over 3 is past. Notice that's bigger than 1, so we're past 180. 4 pi over 3 is right here. And I need the x value of that, so it was over halfway and down, so that's -1 over 2. Much faster than creating right triangles. However, you have to have this memorized. All right, let's look at the next ones. What about sine of 7 pi over 6? So I think 7 pi over 6, that's greater than 1, and we're 1/6 past pi. So it put me right here. Sine is the y value. I'm going to go -1/2. Okay. Now, what about this one? This is kind of tricky. Okay, tangent of 13 pi over 6. I don't have a 13 pi over 6. I have an 11 pi over 6. But I would go 2 pi over 6 past that, which would put me right here. But what you have to do is you have to think, wait a minute, what's coterminal to that? So remember how we could subtract 360 from an angle? What if I subtract 2 pi from that? Well, wait a minute. I don't want to write this as 2 pi. I want to change this as 12 pi over 6, because when I do that, that means that my reference angle, or excuse me, a coterminal angle, with 13 pi over 6 is just pi over 6. So that just means I go right here. Pi over 6 is the same as 13 pi over 6. And what is tangent? Tangent is sine over cosine, which we know as y over x. So I know what y is. That's 1/2. And then I'm going to divide that by whatever x is. In this case, x is square root 3 over 2. Now, once you get the hang of this, you'll be okay. But a lot of kids kind of get confused with, wait a minute, I've got a fraction divided by a fraction. We don't like to divide by fractions. We times by their reciprocals. I'm going to multiply 1/2 times the reciprocal of this. And watch what happens. 2 on top, 2 on bottom, they go away. I'm left with 1 over square root of 3. Okay? But we don't like that answer because it's got a square root in the bottom. So I just have to rationalize it, and that'll leave me with a square root of 3 over 3. Okay? And the last one, tangent of pi over 4. Actually, let's change this. I want to do tangent of 3 pi over 4. So let's just put a 3 here. So tangent of 3 pi over 4. Where is that? That puts me right here. Now notice, what is tangent? Tangent is y over x. Well, with this one, the x and y are almost the same thing. The x is negative and the y is positive. So my answer is going to be square root 2 over 2 divided by negative square root 2 over 2. Now you could multiply by the reciprocal here and things would cancel out, but if I have the same thing divided by itself, that's the same as -1 over 1. Okay, now these problems are really quick when you have the unit circle memorized or printed out in front of you. If we were in the classroom, I would not have this for you to use on tests and quizzes. We are going to expect that you memorize it and use the patterns we talked about. Okay? So let's look at a couple, and we're going to treat this as if we don't have the unit circle in front of us. Okay? So we're going to do a couple examples together just so you can see how this works, and then I'll have you do a couple. Definitely write this down. So our goal is to find the value of sine of 5 pi over 4. Okay? Here's kind of the basic steps that we do. We have to figure out, well, where is 5 pi over 4? You don't have to write these steps down unless you want to. We don't have time to write all of that. So what I want you to do, draw a quick little circle. This is our unit circle. And we want to mark where is 5 pi over 4. Well, if it was 4 pi over 4, that would be all the way around. So I'm a fourth past. Let's do it in a different color. So this big angle here is 5 pi over 4. But what I'm concerned about is where does it end? What's that location? So what is the XY pairing for that? Now again, we're not just looking at our unit circle. We want to think about, well, wait a minute, it's a pi over 4. So I know that if it was a regular pi over 4, this would be square root 2 over 2, square root 2 over 2. Pi over 4s, the numbers are same for x and y. Well, what did we do? We went over to the right and up. Well, what if I go over to the left and down? These are the exact same values. It just means that they're both negative, right? I went to the left, square root 2 over 2, and I went down, square root 2 over 2. So what does that mean? The sign value is always the y coordinate of that. So my answer is negative square root 2 over 2. So that's how I would use the unit circle without having it in front of me, is I'd think about where is it in the first quadrant, and then how do I get to the location where it should be, which this case it's the third quadrant. Instead of going over to the right and up, I went over to the left and down, which made those negative values, but the numbers are still the same. All right, let's try another one. Now notice there's two answers here, two problems, but they have the same angle. So we can determine what that answer is just based off of where we're at. So I want to look at 2 pi over 3. So I'm thinking, okay, if I start here, what if it was just 1 pi over 3, right? 1 pi over 3. So my brain is thinking pi divided by 3, well, that's 180 divided by 3. That's 60 degrees. So that means I'm going to go over half of the circle and up. Now, the reason why I said halfway is so you can make a connection with that. I went over half, which is 1/2 of the way, and then the next one is up the tall length, which is square root 3 over 2. So this is where we would be for 1 pi over 3. But I don't want 1 pi over 3, I want 2 pi over 3. So I need to double this, which puts it right here. So this is the 2 pi over 3. And think of your ordered pairs now. It's going to have the same x and y values, except for instead of going to the right positive, we went to the left negative, and I still went up positive. So this will be negative 1/2 and positive square root 3 over 2. Okay? Now, that doesn't help us exactly, right? That doesn't give us secant or cosecant. What it does give us is we know that secant is the reciprocal of cosine. And isn't cosine just the x value? So if I have negative 1/2, secant is the reciprocal of that. I always just put the negative up top, it doesn't matter. So if I flip 1/2, I get 2 over 1 or negative 2. Reciprocal of cosine, that's how we think of that one. And then cosecant is the reciprocal of sine. Well, if sine is the y value, that's the reciprocal of sine is 2 over square root 3. But we don't like having that square root 3 on the bottom. So we have to change it to 2 square root of 3 over 3. Okay, It's not easy. This stuff takes a lot of practice. The more practice you get with it, the easier it becomes. So we don't have enough time to kind of go through all of these. Let me show you this one right here. Don't write this. I just want to go through it real quickly. We got to find cotangent of 13 pi and sine of 13 pi. Well, wait a minute. If I go around halfway, isn't that 1 pi? And then what if I go around again? Isn't that 2 pi? Well, what if I go around again? And I'm at 3 pi. And then if I go back around again, I'm at 4 pi. And then this will be 5. Notice how 6 pi. These are always going to be the odd. So 7, 9, 11, 13 pi. So instead of drawing all the way around the circle, where am I going to end up? 13 pi is the same as pi. So one of the ways I could write this is cotangent of 13 pi is actually equal to cotangent of just pi. And notice this is one of those tricky ones. This is the quadrantial angle. So what did I do? I went over to the left one up 0. So I know x and y. Well, wait a minute. Cotangent is the reciprocal of tangent. And if tangent was sine over cosine, then cotangent is x over y. And my answer then is, what is x? It's -1. What is y? It's 0, which means I cannot divide by 0, so this function is undefined. And then this problem is really easy. What is sine of 13 pi? Well, sine is always the y value. And here it is. The y is 0. We're done. Okay. I do want to make one point, so please do not log off a minute early. The unit circle on Delta Math, your homework tonight is unit circle practice, 3rd hour. They show you a slightly different way. Okay, I'm not going to redraw this. I don't remember exactly what it is, but I think they give you this chart. We are not going to give you this chart, and you should be thinking about the unit circle. Either use what you have drawn or use the link that I sent to help you answer the problems, but I really do hope that you think about the problems like this. So you're doing the work thinking about where that point would be based off of its reference angle, and then finding the xy value. We're going to spend a lot more time on this next week. So that's all I got. Conferences are tonight from 4 to 7, and there's links that are just sent to your parents so you know. Have a great day. I'll be available in my office hours if anybody has any questions.